So let's talk about graphing linear inequalities. Now, graphing linear inequalities isn't much different than just graphing regular old equations, linear equations, except for a few things. Obviously, we're dealing with inequalities. So we have a few basics that we need to follow. For instance, when you're talking about a linear inequality, you're looking for not just points that are representing on a line, but we're actually looking for a space, okay, a region. And when we're talking about a region, there's going to be some shading involved. And as we go through and solve or graph a few of these, we're going to have to look for whether or not we're looking to shade, I guess, above a line, below a line. And then we're also going to talk about whether or not we're going to include the points that are on the line or not. So as we do this, I got a couple examples here. We're going to fill in some of this top part as we go. It says the basics. And so let's take a look at this first example. So it says 2y minus 3x is less than or equal to 6. Let's change that to slope-intercept form. So if I add 3x, 2y less than or equal to 3x plus 6, divide by 2, you get y is less than or equal to 3 halves x plus 3. So if I graph that just like it's an equation, I would go y-intercepts 3, so 1, 2, 3. And then my slope's 3 over 2, so I go up 1, 2, 3 to the right 2, or down 1, 2, 3 to the left 2. And then I draw my line. Now sometimes we're going to be talking about what we call a solid line, and sometimes we're going to be using a dash line. Now we're going to be using a solid line, so we'll go back up here to the basics. We use a solid line when we're talking about equal to. So less than or equal to or greater than or equal to. And I'll explain why that is here in just a second. So it says less than or equal to, so we're going to draw a solid line. Now what we're talking about here, this is all the y's, okay, that will be less than or equal to 3 halves x plus 3. So we're looking for all the points that will make that true. Well, those points don't just exist on this line. Okay, they exist. There's a much bigger area that will make that true. And what we're going to have to determine is, are we going to end up shading this area, because this is where all those points that will make this true, or this area? Well, one way that we can do that is what we call with a test point. So we're going to test a point on here. We're just going to pick any point we want. I'm going to pick 0, 0 because that's an easy one, and it's not on the line. So we're going to pick 0, 0. So what I'm going to do is I'm going to take 0, 0 and I'm going to plug it into this equation. So I'm going to get 0 less than or equal to 3 halves 0 plus 3. So I get 0 is less than or equal to 3. And that is a true statement. And so if a test point that I pick, you plug it into this inequality, and if it comes out to be true, that means you're going to shade wherever that point is. So 0, 0 is here, so we're going to shade on this side of our line. Well, what does that mean? Well, this shaded region is all the points that you could possibly plug into this inequality and make it true. Every single point on here. If you were to pick the point 5, 0 or the point 9, negative 12, and plug it into this inequality, whether it be this form or this form, it'll make it true. In addition, we have this solid line. We have this solid line because you could also pick any point on this line as well, and it would make this true. Any point over here would make it false. Okay, so when we're talking about graphing linear inequalities, we're not just talking about graphing an actual line, but we're also indicating a region of all the points that would make it true. Okay, so let's take a look at another one. What about this one down here? So I'm going to convert this one also to slope-intercept form. So I'm going to subtract x. We get negative x plus 12 greater than negative 3y. And divide by negative 3. Now I'm dividing by a negative, so my sign has to switch. Negative over negative make a positive, so it's 1/3 x, and positive over negative make a negative. So if I just kind of flip it around, y is greater than 1/3 x minus 4. So I'm going to graph it. So y-intercept's negative 4, 1, 2, 3, 4. And then I go up 1 to the right 3. Up 1 to the right 3. Now this time it's greater than. Okay, and that brings us to back up here to the basics. And anytime it is greater than, we're going to use a dashed line. So it's greater than or less than. So as I come back, I'm going to just create a dashed line. We'll talk about why that is in a second. And then now, where are we going to shade? Well, again, I'm going to do a test point. And I always use 0, 0 because it's easy. And as long as 0, 0 is not actually on this line, you can use it every time. If it is on the line, then you have to pick a different point. So it's not on the line, so I'll pick it. So it's 0 greater than 1/3 x, 1/3 times 0 minus 4. 0 is greater than negative 4. Well, this one ends up being true also. And so what that means is, again, I'm going to shade where 0, 0 is. Now, if this came out to be false down here, if this test point proved to be a false statement, then that means you would shade on the other side of the line. So it ended up being true, so I'm going to shade where 0, 0 is, and it's on this side. So where are all the points that will make this inequality a true statement? Well, they're all in this shaded region. But this time, we cannot include the points on this dashed line. If you pick a point on this dashed line, like 0, negative 4, and plug it into here, it will make it false. And that's why we use a dashed line. We indicate, a dashed line indicates that you are not using these points versus a solid line, which indicates that you are. And there you go. There's the basics of graphing linear inequalities.